Okay, I just want to do a quick video to review the end of last lesson video. So the first thing is we want to go over the 3 different solutions that can affect water balance in cells. The first one's called hypertonic, and that means that there's more water, the 70% inside the cell, and less water out. And so it's always going to move from high to low, like it's written here. And so you can see that the water is going to move out. So hypertonic, the cell shrinks, water moves out of the cell. In hypotonic, the water moves into the cell. There's 100% outside the cell and only 70 in. 70 is the normal number. Water is going to go in to the cell. Cell will get bigger. And then finally, when the cell is in balance, it's an isotonic solution, and that means there's equal flow in and out of the cell, like these arrows show here, and the cell stays the same size. Again, this is what we want. This is the healthy environment for cells. Okay, so you guys have a Google form that you're about to take, and I'm just going to go over how to approach these models, okay? So here we have this circle is supposed to be a cell, and then it's surrounded by some kind of solution, okay? So what you always want to think about is that you're only comparing the amount of water inside the cell to the amount of water outside the cell. And okay, that's number 1. Number 2, water always moves from high to low. That's the definition of osmosis. So because there's 82 in and only 25 out, the water is going to move out of the cell. And when water moves out of the cell, that is called a hypertonic solution. The cell will shrink and get smaller. Okay, the next example, we have 90% water inside the cell and 90% outside the cell. So in this example, there's equal amounts, so therefore there's going to be equal flow in and out of the cell, and this is called an isotonic solution, and the cell stays the same. Okay, in the last example, some of the questions on the Google form, you have to calculate how much water is inside the cell, and remember, it has to equal 100%. So 40 minus 100 is 60, so there must be 60% water inside the cell. We have to do the same thing outside the cell. These two numbers should equal 100%, and so 100 minus 30 would be 70%. So now that we figured out how much water there is, let me just erase this so it's not too confusing for you. Now that we know how much water there is inside and outside the cell, you can predict that water is going to move into the cell because 70 is higher than 60, right? And so because of that, this would be called a hypotonic solution, and the cell would get bigger. And of course, if it's an animal cell, it could explode, just like this picture showing you here. In plant cells, there's not as much change, just in the vacuole. But this poor blood cell over here would burst open if this was a hypotonic solution, if too much water went in, okay? So follow along with these diagrams and do the Google form, okay? If you have any questions, let me know.